Hey everybody. So in this video I'm going to go over the separation of a mixture lab. So you should write all the answers down because you're going to be turning this in on the day of the exam. Okay, so in this lab, in this flow chart, which you all made up, but which we're going to review right now, we start off with a mixture of sand, salt, and iron. Then we weighed the mixture, right, to find the initial mass. And then E is going to be use the magnet, right? Use magnet. Okay. So the sand, the salt part on the right here, the I is going to be non-magnetic because it's not going to be attracted to the magnet. And the F side is going to be magnetic, which means the iron is going to be pulled out over here, and then you're going to weigh the iron. And then on the J side here, we're going to add water so that the salt dissolves, right? Salt is soluble in water. K is we're going to mix so that it's going to help dissolve the salt. And then L is going to be filter. There's the sand part, and that's going to be stuck in the filter, right? Because it's not soluble in water. And P is probably the hardest word. It's called filtrate, right? It's a vocabulary term for the liquid that passes through a piece of filter paper. And for Q, you're going to have salt and water pass through. You're going to heat to evaporate the water, and then you're going to weigh the salt. Then on the sand side, you're going to dry the sand because the sand's going to be wet, and then you're going to weigh the sand. So that's number one. Number two, explain why a flowchart is useful to aid in conducting a lab such as this. Well, basically you're creating a plan of action, and when you map out your steps, you're able to anticipate. Any shortcomings of your procedure. Okay. Differentiate number two, differentiate between chemical and physical properties. So a chemical property is one that can be observed only through changing the substance. So if you were to burn something, right? If you were to burn something, you're able to see if it's flammable, right? That's a chemical reaction, because if you burn a piece of paper, you cannot, you have to actually have to change it in order to be able to see if it could be burned. And then you could do a reacting with hydrochloric acid, right? Like we did in the property of elements lab. So when you react something with hydrochloric acid, either it does or it doesn't. In either case, it's a chemical property. A physical property can only be observed without changing the substance. Without changing the chemical makeup of that substance. So there are many of these. So if you find the mass of something, right, you're not changing it. You find the volume, you're not changing it. Kind of by correlation, if mass is physical and volume is physical, density is also physical, because density is mass divided by volume. There's temperature. There's color, right? To observe the color of something, like this pen color I'm using is blue. So that is a physical property. Define the word soluble. Should be a period there. In the syllab, which of the following was soluble in water? So soluble means the ability to dissolve something. And what was soluble in water? Salt is soluble in water. And what is insoluble? Iron and sand are insoluble, right? They don't dissolve in water. Oops. Okay. Define magnetism. So this one you'll probably have to look up. So I looked it up here. So magnetism is the electromagnetic force, or it's just a force that attracts or repels objects. And which substance was magnetic? Iron is magnetic. Okay. Question number 5. If 5.05 grams, delete that space there. If 5.05 grams sand, 2.78 grams of salt, and 9.52 grams of iron are recovered from the lab, what is the percent composition by each of the components? So the first thing you have to do is you have to add all of them together, right? So I'm going to do that in my calculator. So that's 17, right? Add to get total. 17, oops, let me erase that and try that again. 17.35 grams total. 5.05 grams sand, right? The equation for this is each component divided by the total times 100% will get you the percent of each component. So you do 5.05 divided by 17.35 multiply by 100%, and you get 29.1% sand. So in the next calculation, we're going to do 2.78 grams of salt. And again, divide by the same total. And multiply by 100%. Let me do that in my calculator. And the answer is 16.0% salt. And then to solve the last one, you could add these together and subtract from 100%, or you can just do the calculation like we did before. 9.52 grams of iron divided by 17.35 grams total times 100%. And the answer would be 54.9% iron. Okay, number 6. Okay, number 6 is actually the reverse calculation of the one we just did. You have 40.5% plain yogurt, 35.8% granola. See how the numbers are actually in order with the granola, with the plain yogurt and the granola. So that means, that's what the word respectively means. It means in order. So when the two numbers are given, then two words, it goes in order. The 44.5% is for the plain yogurt, and the 35.8% is for the granola. And then you have the blueberries that are remaining. This line actually was missing from your paper, so please add that. Then you'll be able to actually do the question. So okay, so first we have to get the percent blueberries. And the way you get that is you start off with 100%, subtract the 40.5%, added to the 38.5%. right? To get the two parts added together, subtracted from the whole. So, and that comes out as 21.0% blueberries. Okay, so now you take the percentage, 21.0% blueberries, and you divide by 100%, right, to turn it into a decimal. You can't do math with the percentages, so you gotta divide by 100%. And you multiply it by the total mass. That's why it was so important, and I apologize for leaving it out of the review sheet. So you do 0.21 times 250, and you get 3 sig figs is 52.5 grams of blueberries. On the next one part, you do 40.5% of yogurt, divide by 100%, multiply by 250 grams total, and the answer is 101 grams of yogurt. And then the third part, you can add these two numbers and subtract from 250, or you can just do the calculation like we've already done. 38.5% granola divided by 100% times 250 grams total, and 38.385 times 250 is 96.3 grams granola. And it will not add up to 250 exactly because of rounding, but it's good enough for our purposes. And the last question. After doing the lab, another student received this amounts of each part of the mixture, and it was a total of 10.36 to start off. What was the percent yield? So here's the equation for percent yield. Actual divided by theoretical times 100%. So theoretical is this idea of if the world were perfect, what would you actually get? So if you got 10.36 grams, you should end with 10.36 grams. So that's what goes on the bottom. Now, how do you get the actual? Well, you have to take these numbers and you have to add them together. 2.57 plus 3.50 plus 1.59. So that comes out as 7.66. So 7.66 grams actual divided by 10.36 grams theoretical times 100%, and we will divide that to get the answer. And that answer is 71.0% yield. So you are going to turn this review sheet in with all the correct answers on the day of the exam, and you'll get 10 points, and more importantly, you'll be prepared for the exam. Have a good one. Bye.